Good morning, sir. Sir, good morning.
Good morning, sir.
Sir, we are not able to hear you, sir.
Sir, shall we start with the introduction, sir? Good morning to all the participants of this 1 week online faculty development program.
Sir?
Yeah, am I audible?
Yeah, yes, sir.
Yes,
Yes.
sir. Yes,
Yeah.
sir.
Welcome, sir.
Sir, shall I proceed with the introduction now?
Sir, unmute कर लीजिए, sir.
Yes, yes, please, we can start here. Please.
Yes.
So I welcome all the participants to this day 4, second session of faculty development program on new approaches in geotechnical earthquake engineering. We have with us Dr. Major C.S. Sanghvi sir. He is professor and head at LD College of Engineering, Ahmedabad. He has completed graduation and post-graduation in civil engineering with specialization in structural engineering. He is a doctorate in earthquake engineering, has published more than 70 technical papers in national and international conferences and journals. He has worked as resources honored with National Award of Best Program Officer of National Services Scheme for the year 2017. He has also prepared 18 episodes on earthquake resistant construction for civil engineering professionals with EM2RC Earthquake Multimedia Research Center. And he is the first Indian officer who is associated with armed forces with the rank of major. He has become the Centurion blood donor also. We welcome you, sir, on behalf of the Civil Engineering Department at IPS Academy, Institute of Engineering and Science in Indore. We are honored and privileged that you accepted our invitation and could manage time from your busy schedule to enlighten us today. Thank you so much, sir. I request you to please take over the session, sir.
Very good morning to all of you. And am I audible? Am I audible?
Yes, yes, sir. Yes, sir.
Yeah. Very good morning to all the participants and organizers of this ATAL FDP on new approaches in geotechnical earthquake engineering. We'll start within 1 minute, so just wait for a moment. I'm presenting my screen right now, so just wait for a moment. Yeah. Can Can you see my screen now? Can you see
Now
my
it is
screen?
visible. Yes, sir.
Yes, sir. It's visible now.
Right, right. Okay. Uh, so, first of all, welcome to this ATAL FDP on new approaches in geotechnical earthquake engineering. I appreciate the efforts of IPS Academy Indore for organizing this FDP, and I think last year also they have conducted ATAL FDP. So it's a wonderful approach by the institute, and they keep on organizing this type of FDP uh, in consecutive years. I also thankful to them for inviting me for the session, and uh, today basically I'll talk about the importance of experiments in earthquake engineering. Uh, so you see, when we are talking about the disasters, the various disasters comes in our mind, and uh, out of these all disasters, some of the disasters are some of the disasters are very dangerous, and uh, they are very detrimental to our structures, right? So again, just wait for a moment. Just wait for a moment.
Okay.
Am I audible, right? Again, just checking.
Yes, sir.
Yes, sir.
Yeah. So when we are talking about these disasters, some of the disasters are very detrimental to our structures, and uh, generally when we are list out these disasters, uh, 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 many more will come in our mind, right? So when we are talking about the disasters, the first thing will come in mind is earthquake, right? Uh, why earthquake comes in our mind, and why earthquake is so important for us. Uh, uh, I think we have to understand this part also. Uh, then comes the cyclone. Uh, I think India was hit by many cyclones, and the frequency of cyclone is, I think, much higher than the earthquake. Right. So the cyclone is the another disaster in which uh, we have seen the tremendous devastation also in the past. We talk about the flood, and I think most of the time, uh, uh, the northern part means Bihar, and if you look at the Sikkim, most of the time it is flooded, uh, and if you look at like Gujarat, and Gujarat, our southern portion, like Surat and Baroda, most of the time the the flooding is we are observing. Uh, so these disasters are basically, we have to look at from the structures perspective, and we have to look at the uh, what actually uh, what is the important things we have to keep in mind from disaster point of view as far as our structures are concerned. We have to keep on thinking on this part. We talk about the fire. Uh, uh, See, during the earthquake, the fire also sometimes it taken place. Uh, that may be because of uh, the the electricity, or maybe because of the leakage in the gas pipeline, and many other reasons. Right. So the fire is also is a disaster. in general, we can say without earthquake it may happen, but during earthquake also this fire is going to take in place, right? So um, this fire basically, I think uh, Tokyo earthquake of 1920 is known for the fire. The in during that particular earthquake, Tokyo earthquake, almost the half of the city was under fire because of the uh, gas pipeline was caught fire, and I think this fire also uh, is a secondary disaster which happens because of the earthquake. We talk about the landslide. This landslide also generally it triggers during the monsoon and sometimes during the earthquake also because of the shaking. This landslide triggers. Sometimes we have a we are doing mining activities in the hilly region, and if the explosion is made in this region, then uh, the landslide triggers. So there are many reasons for the landslide because of the slope instability of the soil, right? We talk about the liquefaction. Now, this liquefaction is associated with the geotechnical problem, landslide associated with the geotechnical problem. So, what is liquefaction, first of all? Because we have to understand liquefaction first. Now, this liquefaction phenomena is generally observed during an earthquake, and particularly it is taken place in the soil which is uh, cohesion-less soil. Right? It means if the sand content is more, the sandy soil, then this is going to happen. But you see, we have to understand why this liquefaction is taking place. We are knowing that generally the soil is getting strength from the two perspective. One is cohesion, another is friction. Right? So if we are knowing C and phi. So the soil is getting strength from C and phi. Now, if I'm talking about the cohesion-less soil, then C is 0. Now, if C is 0, then it depends only on the friction, right? So, major component of the strength of the soil or SBC of the soil is concerned. It comes from the friction, is phi component, and therefore, uh, you see, if the water table is high, if the water table is high, suppose the foundation is at the 3-4 meter and water table is at uh, 5 meters, 6 meter, something like that. Now, when the earthquake shaking is taking place, then the water will come up. When the water will come up, then the voids between the sand particle or the soil particle is filled up with the water. Now we are knowing it's a cohesion-less soil or the is a soil in which cohesion is almost is very negligible. Under the circumstances, if the walls are filled with the water, then what happens? There is no friction. So earlier there was no cohesion. Now there is no friction. So we are knowing that soil is getting strength from C and phi. But as it is a cohesion less, there is no cohesion, no C component, or a very minor contribution comes from the C. And then phi, when the water comes up, the pores or voids between the soil particle filled up with the water and friction becomes 0. So C and phi, their contribution is become almost 0. So this soil behaves as a liquid. It means the soil will lose all its shear strength. Soil will lose all its shear strength. It's very simple. I'll give you a very simple example. Suppose if we talk about the water don't have or the liquid don't have the shear strength. So if you try to walk on water, you are not able to walk on water, right? The same way, if the our structure is founded on this liquefiable soil and if earthquake comes and if soil liquefies, the same thing is happening. Our building will be resting on a liquid. Now what is going to happen? Liquid is not going to support your structure, and if liquid will not support your structure, this structure will get tilted. Now here you can see as such damage observed in this earthquake is not seen, but most of the buildings are tilted, right? This is a 1964 Niigata earthquake of Japan. It is a classical example of the liquefaction, I tell you. So this liquefaction is basically uh, uh, very important for the structure. So when you see during the construction of the building, you must have all the geotechnical data, right? Now in 2001 earthquake, 2001 earthquake of Bhuj, right? We have observed a liquefaction also, right? So generally, when we are dealing with the cohesion-less soil, we have to ensure that water table should be low, because so you see liquefaction we need the three conditions. The first condition is uh, the soil should be cohesion-less. The second is water table should be high, and the third condition is earthquake is going to take place. If there is no shaking, there is no problem most of the time. Uh, Now, if water table, the second part is water table. If the water table is too low, like if my foundation level is at 5 meter and the water table is at 80 meter, so as such, no liquefaction problem will arise. But if the water table is high, then the liquefaction is possible, right? So, therefore, you have to be very clear uh, that when you are putting your foundation on cohesion-less soil, you have to be very careful, right? So the liquefaction is one of the major problem as far as cohesion-less soil, which is basically not compacted, right? Not compacted. Now, I'm putting the word not compacted. If cohesion-less soil is compacted, if, even then, uh, uh, if it is compacted, then possibility of the liquefaction reduces or almost become negligible. Right? That is one of the count action which is required to counteract the liquefaction. We talk about the tsunami, right? The tsunami means big water waves comes in the ocean. Now this is also a secondary disaster which is going to take place because of earthquake. Right. So when we are talking about the tsunami, in the tsunami, large water mass, because if you look at if earthquake is taking place below the seabed, right? Now then this because of the vibration, because of the shaking of the ocean bed, the large or huge quantity of water mass is basically agitated, right? Uh, and you see, we are knowing that the depth of the water may be a 5 kilometer or 6 kilometer in the middle. Now, if this water mass is basically excited, and when the uh, water vibrated, uh, right. Now you see the depth of the water is very less near the seashore. Under the circumstances, the huge mass which is actually comes in resonance in the sea where the depth of the water is very high, and when the shaking is taken place, then the effect is seen on the seashore. The large water waves comes in picture, and then we have seen the tsunami, uh, uh, big tsunami in the past also. In 2004, when the Indonesia observed a earthquake of 9.3 magnitude, then the Chennai was affected by a big tsunami. Right? So the tsunami is also is a byproduct of earthquake. You can say it's a secondary disaster because of the earthquake. So we have to be uh, very careful. Now there are many other disasters. You can say there is avalanche. There may be uh, we have a chemical disaster. We have a nuclear disaster. Many disasters that comes in our way, right? So when we're talking about all these disasters, earthquake, cyclone, flood, fire, landslide, liquefaction, tsunami, these are the major disasters I'm talking about from the structure perspective. Now, uh, you see, when we are talking about these disasters, generally we are categorizing these disasters into the either man-made or the man-made, maybe a man-made disaster, or it may be a natural disaster. And most of the time, we are saying the earthquake is a natural disaster. Cyclone, we are saying it's a natural disaster. When it comes to flood, uh, uh, when it comes to flood, we are saying that the flood may be a natural or maybe man-made. Right. Uh, when we are saying that there's a heavy rainfall and there's a low-lying area, then the area is flooded, it is a natural thing, right? Because we have not done anything to cope up with this condition. So, under the circumstances, we say it's a natural disaster. But sometimes, because of the human error, if the area is flooded, then you can say it is uh, man-made also. For example, what we have a flood in Surat, for example. Surat is in Gujarat and is a big city. Now, in 2006, what happened? There was a heavy rainfall in the upstream in the Madhya Pradesh, and then the level of water was rising in the dam, and at that moment, at that moment, uh, the you see we have a flood control cell which uh, monitors the rain in Gujarat, and this control station is at the control uh, tower is in the Gandhinagar. So they keep on observing the water level, and then they decide that when to release water. Right. So the irrigation department, it comes under irrigation department, and they keep on monitoring the water level in all the dams, and then they decide when to release the water. So there was a heavy rain in the upstream in the Madhya Pradesh, and um, then engineers had said that okay, now we have to release the water. So we have to take the permission from the political permission is also required. So it was conveyed to the higher authority that okay, now we have to release the water. At that moment, the politicians said that uh, uh, no, we are not going to release the water, but we are keep on storing this water, and this water will be used in the summer, right? Because there is a scarcity of water in summer, and therefore the intention of the politician is that we want to store the water and we will use in the summer. And the engineers are saying that we have to raise the water. If the water level increases now onwards, then we have to open all the gates at the time, and then the Surat will be flooded. And the same thing was happened, I tell you. There was a heavy rain in the Madhya Pradesh, and this water level was keep on rising. And then the moment came when there is no other option available, that we have to release all the gates, and all the gates were released, and you will be surprised that the whole Surat city was under water. 15 feet, up to 15 feet, there was a water. And at that moment also there was uh, a full moon day, and the full moon day means the water is not going in this sea even, right? So that was another problem, and therefore because of the wrong decision, this flood was taken place. We can say it's a man-made disaster. If you are considering the collapse of any dam during the flood, this was happened in 1979 in Morbi. In Morbi, uh, but basically this Morbi is in the Saurashtra region, and there is always scarcity of water. But in 1979, there was a heavy rainfall, and there was heavy rainfall. There was a Machu Dam. Machu Dam is an earthen dam, right? And there was a good rainfall, and because of this rainfall, the water level rises, and nobody assumed that this much uh, rain will come. Uh, so at that moment, uh, the water level rising, and at that moment they have to release the water, and they have to open the gates. But what happened, because of last 10, 20 years, there was no maintenance of the gate. Right? They have not maintained the gate operations. So when they try to open the gates, when they try to open the gates, but they were jammed, and they were not able to open it. And now it was earthen, and then the water overtops the earthen dam. Now you know what happens yeah, if in case of earthen dam, if water overtops, then this dam cannot survive that pressure and it collapsed. So uh, it was a big disaster in Morbi, and lots of means many lives we have lost in that. So it was a man-made disaster because we have not maintained the operations of the uh, gates. It was a human error. We talk about the fire. So I'm again saying flood. Flood is either man-made or natural. When we're talking about the fire, fire is again a man-made and natural, right? It's again a man-made and natural. Uh, uh, Sometimes because of the faulty uh, uh, design, this fire may have taken place. Maybe uh, overloading, or maybe any other reason this fire may have taken place. It is a man-made disaster, and sometimes this fire may have taken place in the jungle also, and then uh, that may be an actual landslides. The landslide again, uh, uh, it's natural and man-made both, because when we are doing a mining in the hilly region and the explosion is done in the hilly region, we landslide triggers is a man-made. But when the earthquake comes and shaking, because of shaking landslide triggers, it is natural. It is not in our hand. So uh, we will understand this part. Liquefaction. Liquefaction is because uh, of the earthquake. It's taken place, and it is. You can say again here the problem is if you are knowing that you see these all are hazards. These all are hazards. This hazard is converted into disaster only when we are not prepared ourselves against this hazards. That's all, right? If we are okay, we have prepared ourselves for to fight against this disaster, nothing is going to happen. The same thing if we are talking about liquefaction. With liquefaction, we are knowing that uh, this cohesion less value is there, water table is high. So we have to understand that if earthquake will come, there's a possibility of liquefaction. So we have to understand this fact. So if we are neglecting that part, then we are inviting troubles. So liquefaction, we are always saying that it is a man-made disaster. A hazard is natural, but disaster is man-made. Tsunami, we always say it's natural, right? Now, you see, now I'm talking about the earthquake and cyclone. Generally, if you look at the curriculum of engineering, these two things that comes in our mind: earthquake and cyclone, right? For which generally we are designing, and more in the curriculum, we're designing a structure for the cyclone or earthquake. Now we are saying earthquake is a natural disaster, cyclone is a natural disaster. Now, if you look at the condition, suppose uh, you are sitting in your house and suddenly cyclone hits, what is going to happen? Means uh, uh, you will remain in your house, or you will go out? That is the question. So during cyclone, definitely we will try to keep ourselves in a confined environment. We will remain in our house or in our structure, and once it this disaster is over, we can go to the go outside. Now, when we go outside, is a nature basically. So we say the cyclone is a natural disaster. Right? Cyclone is a natural disaster, and if cyclone is a natural disaster, during the disaster, we are not going to approach the nature, right? We are not going to approach the nature. But in case of earthquake, what is happening? Earthquake is something reverse is happening. Suppose if earthquake hits your region, and what you will do? You will try to come out of your building, right? You try to come out of your building. What is why you want to come out? The reason is uh, 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 you means you have a fear in your mind that your building may collapse, right? And who built this building? We have built this building, so we don't have faith in our building, right? And that's why we are going out. In cyclone, we are not going out. In earthquake, we are going out. We are going in open space. Open space is nothing but nature. So in earthquakes, we are approaching nature. In cyclone, we are not approaching nature. Right? So I'm always saying the earthquake is not a natural disaster; it's a man-made disaster. Right? Now, just imagine if all the structures are safe from earthquake point of view, then then I think there's no need to run out of the building or structures, right? So basically, earthquake is a natural hazard, and it is basically a man-made disaster, right? So I'm always saying that earthquakes do not kill, but the unsafe buildings do, right? So earthquake is a man-made disaster, and therefore I'm always saying the solution lies in the building, not in the earthquakes, right? अ, आप अर्थक्वेक के बारे में कुछ भी स्टडी कर लो, काफी ज्यादा कुछ स्टडी करोगे, लेकिन जब तक आप बिल्डिंग सेफ नहीं बनाओगे तब तक आई थिंक यू आर नॉट गोइंग टू beat this hazard. You are not going to win, right? So this is very important. You have to understand that earthquakes do not kill, unsafe buildings do. So only solution is that you have to make your building safe, nothing else, right? And if you look at the effect of disaster, generally two things are associated: loss of life and economic loss. And if you look at this, uh, if you look at the earthquake, if 100 people die in disaster, out of 100, 47 die in earthquake, 45 in cyclone, 7 in flood, and 1 in other disaster. Right. So maximum contribution is coming from the earthquake and cyclone. And if you look at the economic loss, again, maximum contribution is coming from earthquake, 35%. Right. Then 28 from cyclone, and 30 from flood, and 7 from the other disaster. Right. So if you look at the loss of life, if you lose the economic loss is highest in the earthquake, which is therefore you have to study. If you look at the cyclone, in cyclone also loss of life and economic loss is very high. So it is second important disaster for us. And the third is flood. Now why flood? Flood loss of life is less, but if you look at the economic loss is very high. So that I think this you have to understand why the economic loss is very high and loss of life is very less. The reason is we are able to predict flood. हम फ्लड को प्रिडिक्ट कर सकते हैं. फ्लड को प्रिडिक्ट जब करते हैं मोस्ट ऑफ द टाइम, आई एम नॉट टॉकिंग अबाउट सडन इवेंट लाइक collapse of the dam, we cannot predict, but in normal circumstances we are knowing there is a heavy rainfall, and if there is heavy rainfall this area may be flooded, the low lying area may be flooded, that we can predict. So we can predict flood, we can predict now monsoon or rain now a season more precisely, even cyclone even, right? So we are able to predict the flood or predict the rainfall, and therefore we can issue warning. When we issue warning, the people go to the safer side. So loss of life is very less, but at the same time their property and other things get damaged, and therefore economic loss is always there. There may be a agriculture which is affected by this, right? So I want to say one thing, that as far as flood is concerned, we are able to control the loss of life because we are able to predict it. But as far as earthquake is concerned, we are not able to predict earthquake. That is the one of the major thing I want to convey. Right. So we are not able to predict earthquake, and therefore the loss of life and the economic loss is very high. Now, just wait for a moment. Now, if you look at this, and I want to mention one more thing. If you look at the earthquake is also having the potential of triggering many other disasters. If you look at this, like as far design is concerned, we are not considering earthquake and cyclone at a time. Either we consider cyclone or earthquake. Reason is earthquake is very small duration event, and during that small duration the cyclone may not hit, right? So therefore we are not considering earthquake and cyclone at a time. And if we design our structure for earthquake and cyclone, then it will become very robust and it will become very uneconomical, I tell you. So therefore in the past also we have not seen earthquake and cyclone is going to take place at a time. No, but earthquake and it may be followed by the flood. Maybe because of the earthquake, if the collateral damage is observed, then the flooding is possible. Fire is possible because of the earthquake. Right? I had given an example of 1920 Tokyo earthquake that fire caught the Tokyo city, and we have lost almost 1 lakh people. Right? Landslide also triggers because of earthquake. Liquefaction triggers because of earthquake. Tsunami triggers because of earthquake. Right? So there are many things which may be followed by the earthquake. Uh, very good example of this is 2011 Japan earthquake. Right? If you look at the Japan earthquake, then you find that in Japan, a 9 magnitude earthquake hits in 2011. 9 magnitude. Right? Now, when this 9 magnitude earthquake came in Japan, and you see, if you look at the effect of this earthquake, then it was observed that almost Japan was safe. Nothing was happened. Right? Earthquake was very big. 9 magnitude means is a very big earthquake, but almost nothing was happened because Japan is well prepared. Its preparedness regarding earthquake is concerned, Japan is considered to be the best in the world. Right? Because they are knowing, they are basically Japan is on the situated on the ring of fire. When it's ring of fire, then there are possibility of more earthquakes. So they are ready for the earthquakes. Now, what happened because of the seismic earthquake? The tsunami triggers, right? Now, because of tsunami, almost more than 10,000 deaths had been observed. Not because of earthquake, but because of the tsunami. Now, actually, what happened in earthquake? If you want to make our structure safe, generally we are making our structure light, right? When we are making our structure light, uh, uh, now because of the tsunami, these light structures affected a lot, and tremendous devastation had been observed in Japan, right? And after that, uh, uh, the another disaster, that was a nuclear disaster, was taken place. Right, the Fukushima power plant was get damaged, and Japanese people have actually controlled it in a wonderful way. But that disaster was taken place. So Japan earthquake of 2011 is known for the triple disaster: earthquake, tsunami, and the nuclear disaster. So, like if you look at the Mumbai, for example, the Mumbai is having the same potential. I tell you, it is in zone 3, so maybe a big earthquake may come. Uh, this the ocean is there, so possibly tsunami may be there, and there is also nuclear power plant. So all the three possibilities is there, but we have to think: are we ready for the any big earthquake if it is taking place near Mumbai? We have to think about it, right? So when we are talking about the impact of the earthquake, generally the many things is going to happen. The life and society is affected, property affected, semi-amenities, lifetime structures, heritage, economical development. We always say virtually everything is affected, right? And this is ve- uh, very distracting part for the civil engineers. We see loss of life. That loss of life is, I think, it is not acceptable as far as civil engineering is concerned. Right? It is not acceptable for any reason. Under any disaster, your structure should remain safe. Right? Structure should remain safe. We are designing our structure in such a way that it has to resist all disasters. Right? Now look at this picture. Right? Well, now definitely it will distract you as a civil engineer. Right? These are the pictures from Bhuj earthquake, where we are carrying out a rescue and relief operations with the Indian Armed Forces. And such kind of pictures definitely we don't want to see. Right? The township is lost. We can see the loss of the property. This is the building in 2001 Bhuj earthquake. Uh, this was damaged, and this was a ground plus 4-story structure, but it got damaged, and uh, it was a soft story, and a soft story got damaged, and I think you are not able to see the ground story here, right? The whole structure was down by 1 floor, right, because of collapse of the soft story. The same thing is here. You can also see this. This is also uh, a structure where the column has lost all its uh, capacity, right? Now you see this building even survived because as far as the structure is concerned, a lot of redundancy is there. Lot of redundancy. Redundancy means uh, uh, if the one member, like yeah, I'm giving you a very simple example. If a table is having four legs, right? Uh, now, if four legs, and if you remove one leg, then this table will become unstable, right? But uh, if this table we are putting two more legs, right? So there are six legs, and now if any one leg, I think collapse, or if we remove it, then there is possible that the load of this is transferred to other part of the table, right? There's a possibility because you see four legs are required for the stability, yeah, and if you remove one, it becomes unstable. But you have now two more options. Means if you remove two, there is possibility that still it may remain stable. There's a possibility. The same thing is happening in case of buildings. In buildings, the redundancy is very high most of the time. Unlike the bridges, in the bridges we have a very less redundancy, and when we have a very less redundancy, definitely there is a problem. Right. So if one component fails, we have to assume that, like in case of bridge, if one pier fails, then I think we have to assume that it's a partial collapse. But even though the failure of the bridges we have to consider. But in case of bridges, in case of the structures, if one column fails, then the load of this column will transfer to the neighboring column, right? And your structure may remain safe, right? So here you can see this column has lost almost all strength, right? So still building survived. It means there is no loss of life, but there is a loss of property, and therefore economic loss is associated because you have to now retrofit it, or you have to demolish this building and you have to reconstruct it. This is the possibility. uh, the health structure, health centers, they are affected. Like in the hospital in the Bhuj was collapsed in 2001 earthquake. Right now, generally we are designing our hospitals for the higher forces, 1.5 times. Right, but this was collapsed in Bhuj, even though it was designed for 1.5 times force. Now uh, we have to think about it, why it fails. Now hospitals are needed after earthquakes, so hospitals should remain functional. That's why its importance factor is very high, is 1.5 times than the normal design, and therefore it should remain functional after earthquake, right? But it was collapsed. Now this is a very serious thing, right? If you look at the schools, now the schools are generally in Gujarat. It is made up of the prefabricated elements, and almost 2001 earthquake we have lost 12,000 schools, right? And the reason was was a joint detailing was very poor, right? And that was the reason. And 2001 earthquake was taken on the 26th January, so it was a holiday, and therefore casualty was less. Right? That was so we are lucky that it was taken place on a holiday, and therefore loss of life observed is very less. The heritage building affected a lot in Gujarat in 2001 earthquake, and heritage, once it is lost forever most of the time. The reason was we don't have those skilled artisans right now, so it was very difficult to rebuild it or retrofit it or repairing of this possible. You can see one, if heritages get affected, and then it will become very difficult for us to. This is Mani Mandir Morbi affected. It was restored partially, I tell you, it was restored partially after 12, 13 years. So it is very difficult to restore the heritage structures. Right? Lifeline structures affected. This is the railway lines, right? So even though they are affected in the region of Kutch, bridges are affected. We have a roads, right? If the roads are affected, then it is very difficult to carry out relief and rescue operations, right? You can see these are the conditions of roads at that moment. The electric power is generally supply is always shut down at the moment, and harbor structures, they are affected a lot, right? And the industrial structure generally, if they are made up of uh, lightweight sheet, right? Galvanized sheet, and uh, so if they are made of lightweight material, they are safe. But if they are made up with the RCC component, which are very heavy, then definitely it's affected a lot, right? And a loss, which is economic loss, very difficult to estimate, right? So basically, if you look at the hazard vulnerability, the 54% land is vulnerable to earthquake, 8% land vulnerable to cyclone, and 5% land vulnerable to flood. So almost 54% land, India, as far India is concerned, uh, is a potential of earthquake. And you can see this 12% land is liable to severe earthquakes, 18% land is liable to uh, MSK intensity 8, and 27% land is up to 7, right? So we have a big earthquake uh, as far as the northern part is concerned, right? Now, if you look at this, this is very important. That there are 7 major tectonic plates, and uh, we can say that the India is located somewhere here, right? India is located somewhere here. This is the India. So you can see this is a Eurasian plate and this is an Indo-Australian plate. Now this Indo-Australian plate and Eurasian plate, they are colliding on the northeast side, right? Northeast side, right? So this Indo-Australian plate is going below the Eurasian plate. Indo-Australian plate is going below Eurasian plate, and therefore the height of the Himalayas keep on increasing on this side. So tremendous pressure is created. Tremendous pressure is created because of the interaction between the Eurasian plate and Indo-Australian plate. Right. So most of the earthquakes are happening on this boundary. Right. So if you look at this seismic zone map of India, then you find that the northeast, they are in either zone 4 and 5. India is divided into 4 zones: zone 2, 3, 4, 5. Earlier there were 5 zones. Before that we have 7 zones. But in 1984 there were 5 zones, and then in 2002 when it was revised, zone 1 and 2 were merged. So now there are 4 zones: zone 2, 3, 4, 5. And if you look at the 4 and 5, they are the most dangerous zones. So the North India, Northeast India, they are divided into zone 4 and 5 because the reason is the two plates are interacting with each other. The Indo-Australian plate is going below the Eurasian plate, and they are creating pressure, and there are possibility of many earthquakes on this side. If you look at the Gujarat is having also very high potential. Gujarat is not located on the boundary. Remember, Gujarat is not located on the boundary of this is Gujarat. It is not located on the boundary of any plate. So earthquake which is taking place in Gujarat is the intraplate, and earthquake which is taking place on the boundary, they are interplate. Right. So even if you look at in Gujarat, we have a red portion that is the zone 5. It is the Kutch. Kutch has observed two big earthquakes. In 1819, we have a 8.4, and then we have a 7.7 2001 Bhuj earthquake. But if you look at the gap between these two earthquakes is almost 180 years between the two big earthquakes, right? So this zone 4 and 5 is very important. But if you look at the south, in the south, most of the portion is in zone 2 and 3. So south is not on the boundary of the two plates. Therefore, south is a little bit safe from the earthquake. But if you look at the coastal line, in the coastal line, then there is a possibility of uh, uh, the flooding. Like Indonesia, big earthquake taken place. Then the Chennai was affected in 2004, right? So this coastal line is affected, having a more potential of the cyclone, right? Cyclone may hit this coastal line. So I think you can see most of the flood is like in the Odisha and then on the southern part of the country. We have observed. If you look at the epicenter map, the most of the earthquakes are taking place on the boundary of the two plates. You can see epicenter map means we are locating the epicenter of past earthquakes on the map. Then you find that this dots represent the earthquake, and if you compare with the our uh, this part, that here the two plates are interacting, and therefore most of the earthquakes are taken by the boundary. They are interpreted earthquake, but within the plate some earthquake may come, right? Now this is very important, and this is occurrence, global occurrence of the earthquakes. uh, I'm just covering this portion initially, just to make you understand, and then we are shifting to the laboratory portion. But first we have to understand actually what is happening during the earthquake. So when we're talking about global occurrence of the earthquake, uh, the earthquakes are classified on the basis of the magnitude. So 8 and higher is known as a great earthquake, and we are expecting one great earthquake per year. Same way 7 to 7.9, 18, 6 to 6.9, 120. Right? So these earthquakes we are expecting. So if you look at this 5 to 5.9, it's 800 earthquakes per year. 4 to 4.9, 6,200. 3 to 3.9, 49,000. These are estimated. Less than 3,000 per day, 2,000 per day. Right. So 9,000 per day earthquakes, 9,000 per day. These earthquakes are coming regularly. But basically, we are worried about these earthquakes. We are worried about these 140 earthquakes. This is very important. Magnitude is more than 6. इसका value 6 के ऊपर है. A lot of energy released. Now, your structure has to absorb this energy, right? Structure has to absorb this energy. And so you have to be very careful as far as these earthquakes are concerned. These earthquakes releases a lot of energy, and this energy is entering into your structure. So your structure has to absorb. So that's why we are making our structure ductile. Structure ductile, right? We have a moderate earthquakes, like these are the moderate earthquakes, right? And these are the small earthquakes, right? They're the small earthquakes. So generally, if you look at this, the big earthquakes are rare, small earthquakes are frequent, and the moderate earthquakes are occasional. This is what we can conclude from this slide, right? This the energy released in magnitude 3 earthquake is very less, and our structure is able to absorb that energy. So this this earthquake of whose magnitude is less than 3, they are not putting any threat to us, right? So that is a. Just wait for a moment.
No problem, sir.
Yeah. Okay, fine. So basically, the philosophy of architectural design is this: that in a minor shaking, there is no structure. There should not be any structural damage, but non-structural damage is possible, which is repairable. So moderate shaking. Moderate shaking means I'm talking about the 4 to 6 magnitude earthquake. Uh, there is a non-structural damage, and there is a structural damage also, which is repairable. And if your magnitude is more than 6, right, then there is a structural damage. Heavy structural damage is possible, like Bhuj earthquake 7.7. Then we have observed non-structural damage, we have observed structural damage, but the minimum condition is that the structure should not collapse, right? That is the bottom line. So in earthquake resistant design, we are allowing damages in our structure, right? Damage in our structure, right? So this is what the philosophy under minor but the frequent shaking, we have repairable damage in the non-structural, and there is no structural damage. Under moderate but occasional shaking, heavy damage which may not be repairable, but structural damage is repairable. And strong earthquake like a Bhuj or most magnitude is more than 6, generally heavy damage which is not repairable in this non-structural part, and there is a heavy damage in structural part even, I tell you, but there is no collapse. Bottom line is this: there should not be collapse, right? यहाँ पे collapse नहीं होना चाहिए structure, right? अगर structure collapse होता है तो किसी की गलती तो है, right? We have to find out the who are at fault, right? If you look at the past earthquakes, 1994 Northridge earthquake or 1995 Kobe earthquake, if you look at 1990 Turkey earthquake or 2000 Bhuj earthquake, in most of the earthquakes we have seen such kind of pictures. It's America or Japan or even they are America and Japan. They are they are quite good as far as the earthquake preparedness is concerned, right? उन्होंने अपने आप को बहुत तैयार किया है from to fight against earthquake, right? But the Turkey and Burj, uh, India is India is developing country, right? So uh, हमारी प्रायोरिटी ये नहीं है कि वी आर गोइंग टुवर्ड्स earthquake safety. हमारी प्रायोरिटी ये अभी है ही नहीं. The priority is something different. Our priority is poverty. We have to come above the means people should come above the poverty line. Right? So our right now our focus is to provide the basic amenities to the people of the country. Like this is going to happen in all the underdeveloped country or developing countries, right? This is going to happen, and this is happening with our country also. So we have not put any emphasis right now as far as the safety is concerned. So as far as you see, we have a good framework of codes and everything. It is there, and all of us have to follow that. But as far as uh, the authority is concerned, they are not strictly following that part, right? And that was the reason. If you look at the earthquake which is taken place in India in 2001, we have lost almost 14,000 people. 13,805, that is the official number. 13,805 लोग मरे थे. बट जैसा ही अर्थक्वेक जो हमने यहाँ पे देखा है, ऐसा अर्थक्वेक अगर अमेरिका में आया तो 2003 में, उसमें 50 से कम लोग मरे थे. सो लाइफ इज वेरी इंपॉर्टेंट इन दिस डेवलप कंट्री. उन्होंने ये सीखा है कि स्ट्रक्चर कोलैप्स नहीं होना चाहिए, होते हैं, राइट, फिर भी बहुत कम. एंड आई थिंक our philosophy is saying that damage is allowed but the collapse is not allowed. So damage तो सभी जगह, या जापान है या अमेरिका, सभी जगह होगा, लेकिन collapse हमें प्रिवेंट करना है. अमेरिका जापान में होता है collapse, लेकिन बहुत कम as compared to the developed countries like Turkey and India, right? So we have to think about the various lateral load resisting systems. We have to understand that columns, shear walls, pressing systems, mobilizing frames, tubes, right? So basically, you see, earthquake is having three components. Basically 6 components we have, 3 translation and 3 rotations, right? If you look at this, then we have I'm talking about the earthquake components, right? Then it is having a delta x, delta y, delta z, theta x, theta y, theta z, right, in all the 3 directions, right? X, y, and z. You have a rotation even, right? You have a rotation about this axis. You have a rotation about this, right? 6 component. But generally the rotations we are not counting. The reason is rotations are very important for the long structures. Long structure means pipelines. They are laid in 500 kilometers long, right? And if you look at the earthquake wave, the wavelength of the earthquake is 2.5 kilometers. So definitely there's a difference in settlement of the pipeline. But if you look at the structure, small structures like institutional structures, then as compared to the wavelength of the structure, the size of the structure is very less, and therefore your structure is going to observe the 3 translations. Means there is an acceleration in through horizontal direction and acceleration in the vertical direction, right? So we are talking about this. Vertical component is also not important for us if your structure is located away from the epicenter. अगर epicenter से आपका structure दूर है तो vertical component is not important. The reason is the vertical component dies very fast. बहुत जल्दी वो actually vertical component है वो dies out, right? वो बहुत immediately वो मतलब उसका value बहुत कम होता जाता है with the distance. Near epicenter, vertical component is significant, but अगर आप 20 किलोमीटर away from the epicenter चले जाओ तो vertical component की value बहुत कम हो जाएगी, and therefore the original component, two original components are traveling longer distance, right? अगर मैं बात करूं अहमदाबाद की, now earthquake was taken place in Bhuj, तो अहमदाबाद उनसे 300-350 किलोमीटर दूर था, फिर भी अहमदाबाद में tremendous devastation has been observed, but that is not because of the vertical acceleration, that is because of horizontal acceleration, right? बट अगर एपिसेंटर के नजदीक में कोई स्ट्रक्चर है तो वहां पे वर्टिकल एक्सेलरेशन इज आल्सो इंपॉर्टेंट. इन 1897 1897 1897 असम अर्थक्वेक, वहां पे हमने देखा था कि you see this is we have observed that the sand, the stones are moving in upward direction, they are boiling, right, because of the earthquake, because of earthquake, because of shaking of the earth, these stones are moving in the upward direction, right. The meaning is the vertical acceleration is more than 1g, because gravitational acceleration is 1g in the downward direction, the stones are moving in the upward direction. It means the acceleration because of the earthquake is higher than the gravitational acceleration. It is more than 1g. And near epicenter, such kind of phenomena is we have observed. It may be a 1g, it may be a 1.2, 1.5g. This is what we have observed near the epicenter. But when you go away from the epicenter, the vertical acceleration comes means it वो उसकी value बहुत कम होती जाती है, right? And the horizontal component remains for a longer, for means अगर हम आपका structure एपिसेंटर से बहुत दूर है तो horizontal component will become very significant for your structure, right? Now अब आप सोचो कि जो आपका कॉलम है, right? Now जनरली कॉलम जो हम डिजाइन करते हैं, ये कॉलम है, उसके ऊपर कौन सा लोड आता है, डेड लोड एंड लाइव लोड. तो डेड लोड लाइव लोड कौन सी डायरेक्शन में आता है, इट इज कम्स इन द वर्टिकल डायरेक्शन. व्हेन इट कम्स इन द वर्टिकल डायरेक्शन तो उसके ऊपर एक्सियल फोर्स, ये एक्सियल फोर्स है, राइट, अलोंग द एक्सिस ऑफ द कॉलम. सो कॉलम्स आर वेरी कंफर्टेबल. बट ड्यूरिंग अर्थक्वेक क्या होता है, ड्यूरिंग अर्थक्वेक इसके ऊपर लेटरल लोडिंग आएगा, राइट. ये लेटरल लोडिंग आता है. लेटरल लोडिंग की वजह से क्या होता है, व्हाट हैपन बिकॉज ऑफ दिस लेटरल लोडिंग, इसी कॉलम में एक्सियल की जगह नाउ शियर फोर्स एंड बेंडिंग मोमेंट कम्स इन पिक्चर, राइट. सो नाउ ये बैंड भी होगा, उसके ऊपर शियर भी आएगा, राइट. एंड देयरफॉर द कॉलम्स आर नॉट कंफर्टेबल in the earthquakes, right. And we have to design this column in a proper way to resist this earthquake, right. So column, shear walls, bracing system, MR frames, tubes, right. Look at this. This is a moment resisting frame, right. It's made of a beam and column. This is the frame. This is the bracing, right. Cross braced frames. This is with the shear wall strike, right. These are the main structural component. These are normal structural components we are using to resist earthquake. This bracing generally used behind the steel structures. Shear wall we are using in case of RCC structure most of the time, right. So the concrete bracing is a little difficult to provide, right. Same way, in case of steel structure, we are putting the bracings. Right. This is the you can see this is a beam column systems. This is a frame structure, right. Sometimes we go for the bracing to increase the stiffness, right. So there is an X brace frame, chevron brace frame, eccentrically braced frames, varieties of things. It depends on which type of things you have, right. So which type of functional requirement you have. For example, if I'm using the X brace frame, my is clear thing, no doors and windows will be allowed by X brace frames, right. But if I want doors and windows, I have to go for the eccentrically braced frame, or I have to go for the chevron braced frame in case if I want a door there, right. So doors and windows are not possible in case of X brace, but the eccentrically braced frame, doors and windows both are possible. In chevron brace, we can provide doors, right. You can see this as the bracings, right. And the purpose of bracing is to increase the stiffness, right. You see, I'm just creating the background because when we go to the laboratory part, these all are very important. We have to understand this part, and then we can appreciate this thing from the laboratory part. The laboratory part includes geotechnical and structural part, or both, right. Is a shear wall. The shear wall is a vertical wall. It's a concrete wall in the vertical direction. Now, as it is a wall, it is having its moment of inertia for the horizontal load is very high, right. So the moment of inertia of this wall is very high, and therefore the stiffness is very high, and therefore it controls the deformation of the whole structure. So shear wall, in my opinion, is as far India is concerned, it is one of the best option available to fight against the earthquake, right. So this is very important. Before 2001, I think you see the it was not a common practice to provide the shear walls, right? It was not a common practice. Even though when we are constructing the lift, right? For the lift, there is a core we are making. It is generally made out of the concrete, right? It is made of the concrete. But sometimes the people or contractor are making with the masonry bricks they are making, right? So which is very unusual before 2001. I'm saying in Gujarat. But after 2001, the shear wall is a common feature in most of the structures, and it performs very well during earthquake. And construction of a shear wall is very easy. It depends how many layers of the steel is required. It's a 150 one layer is okay. If it is more than 200 thick shear wall or 300 thick, it need 2 layers of reinforcement. So these are the generally the construction of shear wall which is taken place. You can see this dual frame systems where shear wall and frame is there, right? So we have another special system. So it's tubular systems, frame tubes, truss tube, bundle tubes, shear wall without triggers, right? The systems are also there. Right? Now we go to the main laboratory part, right? Now you see what happens in 2001 earthquake. We have seen a tremendous devastation. For 13,805 people died in Bhuj earthquake, right? And then there was a high level committee was formed in Gujarat under the chairmanship of the CM, Chief Minister. At that moment, Narendra Modi was Chief Minister of Gujarat. And this high level committee tried to find out what are the reasons of this devastation because of the earthquake. And there are many reasons comes in because there's a poor quality of construction. There was a the the authority was not very strict, and many other reasons came in the structure design was not proper, and many other things. One of the reason was that the subject was not taught at the undergraduate level of right. That was one of the findings. This earthquake subject was there in is were divided into the other subjects. And now what happens? You see, most of the time when we are trying to cover the syllabus, most of the time this when we reach to earthquake, terms getting closed, right? So nobody is touching this earthquake part very seriously, and therefore uh, the findings of this committee was that this earthquake subject was not taught at undergraduate level, and then it was recommended that earthquake engineering subject should be placed in the curriculum of the civil engineering compulsorily. And in the 7th semester, this earthquake engineering was introduced, and in earthquake engineering we were teaching them the earthquake resistant design and the structural dynamics part, right? Now you, uh, now if you look at the another reason, that is because of the this earthquake, what other thing we learned, that earthquake engineering philosophy, earthquake resistant design philosophy is something different. You see, for if we are talking about a dead load and live load design, now suppose if I'm designing my column for dead load and live load, right? Then what exactly I'm doing? I'm designing my column for 1.5 टाइम फोर्स. मीन्स अगर मेरे कॉलम पे 100 किलोमीटर का फोर्स आता है तो मैं 1.5 फैक्टर सेफ्टी यूज करके 150 के लिए मैं डिजाइन करता हूँ, ठीक है ना? So your column is absolutely safe as far as the dead load and live load is concerned, right? वो कितना भी आएगा क्योंकि हमने 1.5 टाइम फोर्स के लिए उसको डिजाइन किया है, कुछ होने वाला नहीं है. But when it comes to earthquake, in earthquake we are not designing our structure for the maximum force. I tell you, maximum force coming on a structure is very high as compared to uh, uh, your design forces. हम जो स्ट्रक्चर को डिजाइन करते हैं वो मैक्सिमम फोर्स के लिए डिजाइन करते ही नहीं है, राइट? हमारा कॉन्सेप्ट क्या होता है? earthquake resistant design is not a force based design. I tell you, वो हम मैक्सिमम फोर्स के लिए डिजाइन करते ही नहीं उसको. earthquake में क्या होता है? You see, if you look at the whole event in earthquake, the the rock fractures means tremendous amount of energy which travel in form of waves. Now ये जो earthquake waves है, it will shake the foundation, वो foundation को shake करेंगे. It means some of the energy is entering into your building, and our motive is that the energy which is coming into your building has to absorb this energy. That's all, right? So the whole earthquake engineering is based on energy absorption, not on the strength. Our basically, if you look at the design part, 100 kN force is coming, we are designing for 30% force or 40% force. We are not designing for the 100% force even. So our design is earthquake resistant design. It is not an earthquake proof design. As our design is earthquake resistant, and therefore we are allowing the damage. This is the only philosophy where damage is allowed. This is the only philosophy where damage is allowed. Right? And therefore this become very important. So generally we are relying on energy absorption, and therefore we are making our structure ductile. हम अपने स्ट्रक्चर को डक्टाइल बनाते हैं. डक्टाइल बनाने से क्या होगा, वो अर्थक्वेक जितनी भी एनर्जी सप्लाई करेगा वो एनर्जी आपका स्ट्रक्चर एब्सॉर्ब कर पाएगा, राइट? So again I'm saying we are not designing earthquake proof structures. Earthquake proof अगर हम बनाते हैं तो उस earthquake proof में क्या होता है, जितना earthquake force आता है उसके ऊपर हम फैक्टर ऑफ सेफ्टी अप्लाई करेंगे and then we design. लेकिन earthquake में हमारे तो क्या होता है, earthquake force जितना आता है उससे हम 30% force के लिए डिजाइन करते हैं, right? 30 we ensure के earthquake का जो एनर्जी है वो हमारा स्ट्रक्चर एब्सॉर्ब कर लेगा. That's why damage is allowed. हम डैमेज को अलाउ कर रहे हैं हमारे स्ट्रक्चर में. रिमेंबर, डैमेज इज अलाउड, राइट? सो ये जो एक फाइंडिंग आया कि भी ये अर्थक्वेक सब्जेक्ट नहीं था, अर्थक्वेक सब्जेक्ट इंट्रोड्यूस किया गया, और नाउ ये सब्जेक्ट को समझना वो भी थोड़ा डिफिकल्ट है. मैंने आपको बताया कि डेड रोड डाई रोड में फिलोसफी इज डिफरेंट, राइट? नो डैमेज कंडीशन, बट अर्थक्वेक में डैमेज कंडीशन, अर्थक्वेक रेजिस्टेंट डिजाइन आता है. इट्स नॉट अर्थक्वेक प्रूफ डिजाइन, राइट? तो ये जो बिहेवियर है वो उसको समझना बहुत इंपॉर्टेंट है. अगर हम उसको समझेंगे नहीं तो डिफिकल्ट हो जाएगा. एंड देयरफॉर हमने जब देखा कि जैसे कि किसी को हम बताते हैं कि भाई इट इज अ सॉफ्ट स्टोरी बिल्डिंग, राइट? अब अगर मैं अहमदाबाद की बात करूँ, अहमदाबाद में 128 बिल्डिंग्स वर कोलैप्स्ड व्हिच वर ग्राउंड प्लस 4 स्टोरी. ग्राउंड प्लस 4 स्टोरी के 128 बिल्डिंग गिरे थे. उसमें से 95% बिल्डिंग जो गिरे थे उसमें ग्राउंड फ्लोर पे पार्किंग था, और पार्किंग की वजह से वहां पे वॉल नहीं थी, सिर्फ कॉलम थे, और फर्स्ट फ्लोर पे कॉलम एंड वॉल थी. इज अ सॉफ्ट स्टोरी. अगर ये सॉफ्ट स्टोरी अगर हम यहाँ पे हम देखते हैं सॉफ्ट स्टोरी, तो सॉफ्ट स्टोरी फेलियर हमने देखा काफी, लेकिन nobody is able to appreciate कि भाई ये क्यों हो रहा है. अगर जब लेबोरेटरी में एक्सपेरिमेंट करेंगे, अगर वो देखेगा कि सॉफ्ट स्टोरी में क्या होता है, और अगर सेफ स्टोरी में समझ गया कि भाई ये ऐसा होगा, देन दे कैन रिकॉल. सो हमेशा हम बिलीव करते कि हम कुछ बोलते हैं, जैसे हम पढ़ते थे तो हमारे प्रोफेसर बोलते थे कि भाई ये सॉफ्ट स्टोरी है, राइट? और उसमें क्या होता है, या तो अर्थक्वेक में क्या होता है, राइट? रिजोनेंस क्या है, वो हम जो प्रोफेसर बोलते थे उसको हम विजुअलाइज करते थे. लेकिन यू सी हमको ये नहीं पता था कि ये एक्चुअली क्या होगा. हमने कुछ देखा नहीं था एक्सपेरिमेंट पॉइंट ऑफ व्यू. उसी वजह से मैंने आपको बताया कि 2001 के पहले यहाँ गुजरात में एक भी अर्थक्वेक लैब नहीं था. अर्थक्वेक लैब एक भी नहीं था, राइट? सो अर्थक्वेक लैब अगर बनता तो वहां पे काफी सारे एक्सपेरिमेंट होते, और एक्सपेरिमेंट से पता चलता कि सच में ड्यूरिंग अर्थक्वेक क्या होता है अपने स्ट्रक्चर्स के ऊपर, राइट? सो अर्थक्वेक लैब इज वेरी इंपॉर्टेंट फ्रॉम स्ट्रक्चर, फ्रॉम अंडरस्टैंडिंग पॉइंट ऑफ व्यू. ये बहुत जरूरी है. तो ये अर्थक्वेक लैब की जरूरत क्या है, क्यों जरूरत पड़ी? बिकॉज अर्थक्वेक इज अ रैंडम स्ट्रॉन्ग ग्राउंड मोशन. वो बहुत ही स्ट्रॉन्ग ग्राउंड मोशन है, और इट इज वेरी कॉम्प्लेक्स इन नेचर, राइट? और ये अर्थक्वेक का एनालिसिस बेसिकली इज डायनेमिक इन नेचर, सो यू टू कैरी आउट डायनेमिक एनालिसिस इफ यू वांट टू बी मोर प्रिसाइज. अगर आप प्रिसाइज बनना है तो आपको डायनेमिक एनालिसिस करना पड़ेगा, राइट? सो दैट इज टू बी रिक्वायर्ड. देन you see we have a IS code 1893/2016 and many other codes we have, but ये earthquake force सब में फिलोसफी तो सब डिफरेंट ही है. मतलब वही normal civil service ये अलग है, earthquake resistant design philosophy है, right? Where collapse is not allowed, damage is allowed, right? Damage is allowed. So earthquake force is much. If you look at this, earthquake force is much higher as compared to the design forces, right? हम जो design में count करते हैं उससे तो earthquake forces बहुत ज़्यादा होता है, right? So damage is allowed, but collapse is not allowed. This is the bottom line, right? So we have to understand the behavior of the structure in the laboratory, right? And therefore, laboratory testing of the physical model that is to be required to understand the complex behavior. And the shake table is the one of the one of the main instrument we need to test the model, right? Now, अब लेबोरेटरी की टेस्टिंग की बात करते हैं हम, तो टाइप्स ऑफ लेबोरेटरी टेस्टिंग में we have different types of tests. Dynamic test of model means free vibration test करते हैं, जिसमें initial displacement test, initial velocity test आता है. We perform the 4 test. उसमें resonant test होता है, variable frequency with the sinusoidal excitation, transient vibrations. उसका भी हम तो वाइब्रेशन मींस शेक टेबल टेस्ट करते हैं, क्वाजी स्टैटिक टेस्ट और pseudo dynamic or real time dynamic hybrid test, or we can also perform an ambient vibration test for some properties, right? So these are the tests generally we perform, and today basically we are going to discuss this part, right? We are not going to discuss all of them, but we are going to discuss some of them. We are going for the free vibration test, initial displacement test, initial velocity test, right? Force vibration में हम ये resonance test, variable frequency with the sign excitation और shake table test, ये हम आज discuss करने वाले हैं, right? Now हमें क्या चाहिए, laboratory equipment चाहिए क्या? We need equipment to provide a dynamic force. हमें dynamic force के लिए क्या चाहिए? Earthquake simulator चाहिए. हमें simulator means shake table चाहिए पहला, तो शेक टेबल. देन हमें चाहिए मॉडल, जो प्रोटोटाइप या तो स्केल या तो एक्सपेरिमेंटल मॉडल, वो हमें बनाना पड़ेगा, उसके ऊपर टेस्टिंग करेंगे. देन इंस्ट्रूमेंटेशन, हमें अगर टेस्ट करेंगे, अगर उसको अगर हम ऐसे टेस्ट करेंगे तो हमें सिर्फ बिहेवियर पता चलेगा, लेकिन उसका वैल्यू क्या है पता नहीं चलेगा. सो वी नीड अ इंस्ट्रूमेंटेशन फॉर दैट टू मेजर द रिस्पॉन्स ऑफ द मॉडल, वो भी चाहिए हमें. सो बेसिकली ये जो डेटा एक्विजिशन सिस्टम है, इंस्ट्रूमेंटेशन मींस आई एम टॉकिंग अबाउट डेटा एक्विजिशन सिस्टम. इन उसमें डेटा एक्विजिशन सिस्टम में डेटा लॉगर भी होता है, सेंसर्स भी होते हैं, काफी सारा होता है, राइट? So basically we need 3 things. One is a shake table, then model and the instrument. Instrumentation होगा तो उसका you can calculate, you can means quantify the response. आपको उसका response पर कितना acceleration आया, कितना displacement होता है, everything you can have. Now we talk about the shake table. The shake table is having is a laboratory equipment we have already discussed. वो हमें earthquake motion के लिए चाहिए, वो 6 degree of freedom जो होता है, right? With a complex servo means आपको servo hydraulic system चाहिए, वो 6 degree freedom के लिए. You need a prototype scale models, right? ये shake table testing करते होते हैं linear and non-linear structure भी है, दोनों, मतलब आप लीनियर रेंज में भी उसको टेस्टिंग कर सकते हो, उसको नॉन लीनियर रेंज में भी ले जा सकते हो, एंड डैमेज भी ऑब्जर्व कर सकते हो, राइट? एंड द शेक टेबल टेस्ट जनरली जब हम कॉलेज पे जाते हैं तो उसका नॉन लीनियर स्टेज में जाएगा तभी वो कॉलेज होता है, ठीक है? नाउ इफ यू लुक एट द फैसिलिटीज अवेलेबल वर्ल्ड वाइड, नाउ tremendous facilities available in America, Japan, New Zealand, and many other developed countries. In India also we have good facilities at certain places, right? But if you look at this is the earthquake simulator, which is, it is a shake table. It's in a UC Berkeley, University of California, Berkeley, right? Now, if you look at the size, the size is 20 feet by 20 feet, right? And payload capacity you can see very high. Basically, it's a servo hydraulic actuator controller, right? It is having 8 actuators in horizontal direction, 4 actuators in vertical direction, right? Now you see the costing of the shake table is very high, Right. This actuators, what you need, its costing is very high. If you look at, if you refer the actuator from the MTS, this company is supplying, maybe it costing you maybe 70 lakhs, 90 lakh, 1 crore, more than, right? Depends on your requirement, right? But this shake table is able to produce the original acceleration 1.5 G, right? 6 degrees of freedom. I told you 3 rotations, 3 transitions is possible, right? So that is we have the earthquake simulator at NIAD, Mica, Japan, right? Now, if you look at this, the size of this shake table, then it is world's biggest shake table, 20 meter by 15 meter. Right now, नेपाल में एक बहुत बड़ा शेक टेबल आ रहा है, नेपाल में भी अभी, नेपाल में जो earthquake आया था उसके बाद उन्होंने ये शेक टेबल फैसिलिटी वहाँ पे वो डेवलप कर रहे हैं, उसका साइज भी काफी काफी ज्यादा है। या जस्ट देखो 1200 टन कैपेसिटी, राइट? ये 1200 टन कैपेसिटी इज वेरी हाई, राइट? And if you look at the horizontal and vertical direction, maximum acceleration is 900 cm per second, right? So that is the that can be generated. Maximum velocity, it is 2000 mm per second, right? In horizontal direction, it is 700 mm per second. Maximum distance is 100 centimeter, 50 centimeter, right? In the Z direction, in vertical direction, right? So you can understand the size of this shake table, right? It can be tested at low frequency, it can be tested on a high frequency also, right? It is a servo hydraulic, electro servo hydraulic shake table, right? This is the picture from this shake table from Roorkee, right? The Roorkee is having good facility, right? Roorkee is having very old earthquake lab, right? Before 2001, I have seen the laboratory here only, but after that, means there are many earthquake lab came like SERC Chennai. We have a good lab in Kanpur. We have a good lab in other IITs also. But you see, most of the time, this earthquake lab is actually uh, provided in this well-known institution only. But the normal institution, uh, I think we have not seen. You see, if you look at the Gujarat, we don't have the earthquake lab before 2001. Right? We have created the first lab in 2003 in Gujarat. We understood this lab is required to understand the behavior. Right? So still till today, I tell you, because Gujarat has seen the earthquake, and therefore we understand the seriousness of this, and therefore I tell you that we have developed labs in the many institutions even, right? Uh, but in other, like if I look at the other states, MP or Rajasthan or many other states, UP and all that, right? This lab is not available. Right? Because you see, we have learned, Gujarat has learned something from the earthquake, and they try to basically go for the capacity building. And they as a part of this lab was developed in many institutions. But if you look at the UP is also in a is at a location where uh, uh, it may hit by the big earthquake, right? वहाँ पे potential बहुत ज़्यादा है earthquake का. If you look at the Delhi, दिल्ली भी उसमें पोटेंशियल बहुत ज़्यादा है. If you look at the northern boundary, right? कश्मीर से आप देखो, यहाँ पे वहाँ नॉर्थ से आप देखो, तो उसका डिस्टेंस, दिल्ली का डिस्टेंस 300 किलोमीटर है. अब देखो 2001 में भूकंप आया था भुज में, और अहमदाबाद 300-350 किलोमीटर दूर था, तो उसकी हालत बहुत गंभीर थी. आई टेल यू, हमने जो देखा है अहमदाबाद में, वो बहुत ही खराब था. वही चीज आप देखो कि अगर दिल्ली, वो भी 300 किलोमीटर दूर है नॉर्दर्न पार्ट से, तो वहां पे अगर कोई भूकंप आता है, इस दिल्ली इज रेडी? अब दिल्ली रेडी नहीं है, आई टेल यू, राइट? तो ये जो अर्थक्वेक लैब थी वो कोई मतलब बिग इंस्टीट्यूशन लाइक आईआईटीज और वहीं पे मोस्ट ऑफ द टाइम ये अवेलेबल था, और कुछ सारे इंस्टीट्यूशन पे अवेलेबल था, लेकिन नॉर्मल इंस्टीट्यूशन में ये लैब अवेलेबल नहीं था, एंड देयरफॉर यू सी हमने क्या किया, वो मैं आपको शेयर करूंगा. ओके, नाउ इफ यू लुक एट दिस, टेस्टिंग कौन से लेवल पे होता है, ये यूसी बर्कली में 1/5 स्केल मॉडल, ये मॉडल 1/5 साइज है, ठीक है. वो 7 स्टोरी आरसी फ्रेम बिल्डिंग वो टेस्ट करता है. नाउ यू कैन अंडरस्टैंड कि उसकी कैपेसिटी क्या है, राइट. तो इसके पीछे बहुत ज्यादा खर्चा भी होता है. वो पहले तो लैबोरेटरी फैसिलिटी आप डेवलप करते हो, उसका खर्चा इट इज इन क्रोर्स. अर्थक्वेक लैब डेवलप करना ऐसा, तो उसका खर्चा करोड़ रुपीस में आता है. तो पहले तो लिमिटेशन ऑफ इंडिया का वहीं पे रह जाता है कि इतना सारा खर्चा हम कैसे करेंगे, राइट. इतना सारा कहाँ पे मिलता है, तो इतना आधुनिक लैब डेवलप करना बहुत डिफिकल्ट हो जाता है हमारे लिए. ये देखो 7 स्टोरी बिल्डिंग 1/5 स्केल में वो टेस्टिंग कर रहे हैं, राइट. So you need a good shake table. You need a financial approval for this, making them such models, and then you also need the instrumentation part, right? Very good instrumentation part, and then the analysis of this building is to be carried out after the testing, right? So numbers of things you require, right? So basically हमारा उद्देश्य ये था कि अगर हम ये बात करते हैं कि अर्थक्वेक लैब डेवलप करना, उसमें आप करोड़ों रुपए लग जाएंगे, तो कोई भी संस्था उसको डेवलप ही नहीं करेगी, है ना. एंड देयरफॉर वी कम अप विद अ आइडिया दैट ओके, हम 6 डिग्री ऑफ फ्रीडम वाला शेक टेबल डेवलप नहीं करेंगे. वी गो फॉर द यूनिएक्सियल शेक टेबल. क्यों? हमें पता है कि रोटेशन इज नॉट इंपॉर्टेंट फॉर द नॉर्मल स्ट्रक्चर. इट इज द रोटेशनल कंपोनेंट ऑफ द अर्थक्वेक इज इंपॉर्टेंट फॉर द लॉन्ग स्ट्रक्चर्स लाइक पाइपलाइंस, बट नॉर्मल स्ट्रक्चर वो रोटेशन कंपोनेंट इंपोर्टेंट नहीं करता है, राइट. सो जनरली वी टॉक अबाउट द 2 horizontal component and 1 vertical component, right. And I told you that epicenter is nothing, vertical is important, but epicenter is a do, horizontal is important. So we are saying that horizontal is predominant component for all, so most of the structures. And अभी क्वेश्चन आता है कि अभी हमें 2 ओरिजिनल कंपोनेंट लेना है, राइट. तो दो हमें बायोएक्सियल शेक टेबल चाहिए. नहीं, बायोएक्सियल हम नहीं करेंगे. हम क्या करेंगे, मॉडल जो है, मॉडल को 90 डिग्री घुमा देंगे और उसका टेस्टिंग करेंगे. तो उसका 90 डिग्री पे हमारा दूसरा टेस्टिंग होता है. सो हमारा कोड बोलता है कि कंसीडर वन डायरेक्शन एट ए टाइम. सो दैट्स व्हाई वी आर कंसीडरिंग वन डायरेक्शन एट ए टाइम, और हम उसके ऊपर अपने मॉडल का ओरिएंटेशन अलग अलग करके टेस्टिंग करते हैं, राइट. आई टोल्ड यू दैट 6 डिग्री ऑफ फ्रीडम अगर बनाना है तो बहुत कॉस्टली है, राइट. बहुत कॉस्टली है. अगर कॉस्टली है तो कोई संस्था उसको परचेज नहीं करेगी. और हमारा पर्पस ये था कि सबसे पहले तो अर्थक्वेक जो है, मतलब ये सब संस्था में जाना चाहिए सबको, मतलब ये कंपलसरी इंट्रोड्यूस तो कर ही दिया था सब्जेक्ट के फॉर्म पे. और बेसिकली just wait for a moment, just wait please, just wait.
No problem, sir.
So we are talking about not talking about a 6 degree of freedom. Am I audible?
Yes, sir. Yes,
Yeah.
sir.
So we are not talking about a 6 degrees of freedom. We are talking about only uniaxial, only 1 degree of freedom. और उसमें से हम होरिजिनल कंपोनेंट का ही स्टडी करेंगे. अभी बेसिक पर्पस हमारा ये था, और हमारा पर्पस ये भी था कि हमें सब लोग तक पहुंचना है. दैट इज द मेन पर्पस. एंड देन वी हैव क्रिएटेड द शेक टेबल. So basic, it is 8 feet by 4 feet shake table was developed. Then we have developed a 5 feet by 3 feet shake table. Then 2 by 2 feet shake table we have developed, right. हमने एक्चुअली ये जो प्रोजेक्ट लिया था वो विद हेल्प ऑफ GSDM है, गुजरात स्टेट डिजास्टर मैनेजमेंट अथॉरिटी के साथ लिया था हमने। और उसमें हमने 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 हमारा अनुभव क्या था, हमने यहाँ पे LD इंजीनियरिंग कॉलेज में एक अर्थक्वेक लैब बनाया। तो उस टाइम हमारे पास फंडिंग नहीं था, हमारे पास कुछ भी फंडिंग नहीं था, और हमने ये जो शेक टेबल है, ये वाला 8 फीट बाय 4 फीट, ये जो शेक टेबल है, पूरा शेक टेबल हमने जो बनाया था, यहाँ पे हमारे पास जो मटेरियल था स्टोर में, जो वेस्ट था, वो ही लेके हमने उसमें से शेक टेबल ये बनाया पूरा, ये 8 फीट बाय 4 फीट। और ये बेसिक था हमारा हमारा मतलब ये नहीं था कि हम एक रिसर्च लेवल की लैब बनाए, उसमें तो बहुत सारा पैसा चाहिए, लेकिन वी वांट टू मेक अ लैब विच डेमोन्स्ट्रेशन पर्पज से होना चाहिए, राइट। तो हमने ये शेक टेबल बनाया और हमने काफी सारे मॉडल्स बनाए, राइट। और ये मॉडल्स बनाने के बाद जब हमने क्या किया कि वो टेस्टिंग हम करते थे, और उसके बाद हमने वी आर कीप ऑन इनवाइटिंग अदर इंस्टीट्यूशंस। तो काफी सारे आर्किटेक्ट्स आए, काफी सारे प्रोफेशनल इंजीनियर्स भी आए, काफी सारे इंस्टीट्यूशंस भी आए। तो वो लोग आते गए और उन्होंने इतना फीडबैक, जैसे हमने उसका इनोवेशन किया था, तो उसमें हमारे MP आए थे, सुरेंद्र पटेल, वो MP थे, वो सिविल इंजीनियर भी थे, राइट। अगर सिविल इंजीनियर थे तो वो आए और उन्होंने देखा ये जो सारे एक्सपेरिमेंट्स, तो उन्होंने वही बताया कि अगर अर्थक्वेक के पहले ये बनाया होता तो उसका इम्पैक्ट क्या आता। तो ये तो उसका काफी सारे अच्छा इम्पैक्ट। तो आप सोचो कि जो इवन मेशन है, दे आर एबल टू अंडरस्टैंड, अगर कोई स्कूल के बच्चे आते दे आर आल्सो एबल टू अंडरस्टैंड। तो ये जो एक्सपेरिमेंट जो हमने जो लैब डेवलप किया छोटा सा, तो ये लैब डेवलपर हमने जो किया था, कैसे किया था कि पैसा तो था नहीं उस टाइम, और कोई फंडिंग भी नहीं था, तो हमने बोला कि लैब तो करना ही करना है। तो हमने दिसंबर में एक प्रोजेक्ट लिया, और दिसंबर में वी हैव इन्वॉल्व अवर PG स्टूडेंट्स, और उसमें हमने हमारा PG स्टूडेंट को सब ग्रुप में डिवाइड कर दिया, दो स्टूडेंट्स एक ग्रुप में। और तो उस हिसाब से हमने काफी सारे मॉडल्स दे दिया सबको, और ये शेक टेबल बनाना भी दिया। तो दो स्टूडेंट के बीच वो शेक टेबल बनाना था। तो ये जो शेक टेबल बना, वो जो हमारा मैंने बताया ना 8 फीट बाय 4 फीट, वो हमारा जो वेस्ट मटेरियल था उसके अंदर से बना। हमने बाहर से वो मोटर और सब कुछ जो लाए थे, वो सारा का सारा जो पोर्शन था, वो हमने सेकंड हैंड मोटर थी और सब कुछ ऐसा था, राइट। लेकिन ये सारा डेवलप करने के बाद यू सी हमें ऐसा लगा सबके रिस्पॉन्स के हिसाब से कि ये हमें डेवलप करना चाहिए, राइट। एंड आई टेल यू, ये जो PG स्टूडेंट्स ने इससे पार्टिसिपेट किया ना, सबको ये प्रोजेक्ट खत्म करने के लिए 10 मार्क मिले थे। For 10 marks they have done a remarkable job। और उसका हमें करीबन 2 साल ये तक ओपन रखने के बाद हमने क्या किया, वी हैव रेज्ड अ प्रपोजल टू गुजरात स्टेट डिजास्टर मैनेजमेंट अथॉरिटी, GSDMA। हम GSDMA के पास गए और उनको बताया कि ये एक लेबोरेटरी है, वहां का मतलब ये काफी सारे लोगों का अंडरस्टैंडिंग में बढ़ता है, तो हमें कुछ ऐसा करना चाहिए कि हम एक शेक टेबल और मॉडल्स डेवलप करते हैं, और ये शेक टेबल मॉडल्स डेवलप करते हैं और उसको हम हर एक संस्था में देंगे। और उसका कॉस्टिंग कितना, तो कॉस्टिंग यू लुक एट, उस टाइम हमारा कॉस्टिंग था 4.5 लाख, सिर्फ 4.5 लाख। अब 4.5 लाख में पूरा आपका एक सेटअप तैयार हो जाता है, शेक टेबल विद द मॉडल्स। 8 मॉडल्स वी हैव क्रिएटेड, और ये 8 मॉडल में वी कैन परफॉर्म 20 to 25 टेस्ट हम उसके ऊपर परफॉर्म करते थे, राइट। तो हम ऐसा कि एक मॉडल लो, तो एक मॉडल के ऊपर आप काफी सारे टेस्ट कर सकते हो, उस हिसाब का मॉडल हमने बनाए थे। तो ये कॉन्सेप्ट के साथ हम GSDMA गए थे, और GSDMA ने और ये प्रपोजल को रिव्यू किया, और उसमें IIT गांधीनगर के डॉक्टर सुधीर जैन वाज अ रिव्यूअर। उन्होंने बताया कि ये जो है वो दिस मे बी अ वेरी गेम चेंजिंग, ये जो है पोर्शन अगर हम सबको दे पाते। तो ये जो शेक टेबल है, ये आप देख रहे हो 5 फीट बाय 3 फीट, ये IPS एकेडमी में भी अवेलेबल है, वहां पे भी ये सेम टाइप ऑफ शेक टेबल अवेलेबल है विद द कंट्रोल पैनल। तो ये इट्स अ मैकेनिकल शेक टेबल, आई टेल यू, मैकेनिकल शेक टेबल। और ये मैकेनिकल शेक टेबल जो है वो हमने डेवलप किया, और इसका कॉस्टिंग 3.5 लाख, या सॉरी 4.5 लाख, 4 लाख, सॉरी 4 लाख समथिंग था, और मॉडल्स लेके 5 लाख के अंदर हमने ये पूरा शेक टेबल और मॉडल्स बना दिए थे, और 18 इंस्टीट्यूट इन गुजरात उनको ये एक्चुअली दिया था, राइट। तो नाउअडेज आप देखो कि पूरे गुजरात में करीबन 60 इंस्टीट्यूशन के पास यही सेटअप है, राइट। तो ये एक बेसिक सेटअप तैयार हो गया कि ये नहीं था एक्चुअली, कुछ एक्सपेरिमेंट अवेलेबल थे, लेकिन ये सेटअप अवेलेबल नहीं था जिसमें आप स्ट्रक्चरल बिहेवियर को समझ सको। और आई टेल यू, दिस वाज माय पीएचडी टॉपिक, ये मेरा पीएचडी का टॉपिक भी था कि ये ऐसी लेबोरेटरी बनाना। तो हमने लेबोरेटरी बनाने के बाद उसका पेटेंट वो नहीं लिया, रॉयल्टी की बात नहीं थी, हमें ये सबसे मतलब ज्यादा से ज्यादा इंस्टीट्यूशन के पास इसको पहुंचाना था, दैट वाज आवर आइडिया, and I think our purpose was served, and right now we are also working in this direction also, right? And now if you look at the shake table, then uska frequency range 0 to 25 hertz, payload capacity 500 kg,
Hello.
और uska hello, yes please, stroke length 2 mm to 60 mm tha, right? This is the instrumentation setup. Isme we have a 16 channel vibration analyzer, we have a uniaxial accelerometer and triaxial accelerometer, means uniaxial sensor and triaxial sensor, right? ये सारी चीज हमारी, और now this we come to the experimental setup, उसमें हम क्या करेंगे, we are going to discuss that part, और क्या क्या टेस्ट परफॉर्म करेंगे उसका मैं कुछ आपको वीडियो और सब कुछ बताऊंगा, लेकिन आई थिंक शर्मा साहब, shall we take break or shall we continue? Hello. 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 Am I audible?
Hello. Yes, sir.
Hello. Yeah. Shall we continue or shall we take a break? Hello. Hello.
Continue, sir. Continue.
We'll continue. Okay. There's no lunch break, right? So we'll continue. Hello.
Yes, sir.
Yeah. Shall we continue, sir?
सर शायद है नहीं।
हाँ। So what should we do? I'm very comfortable with both the if you want a lunch break, then we'll continue after the lunch break, and if you want to continue,
Sure,
I'm also comfortable.
Sure, sir.
So what should we do?
Okay, sir. Actually,
Yeah.
sir, am I audible, sir?
Yes, sir.
Sir, actually, we have some network issue. That's why we are not able to connect during the time.
Okay.
So we'll start at 2 p.m. sir.
Okay, I'm comfortable. Fine. Right? Yeah.
Sir,
sir,
am I audible, sir?
हाँ, आप ऑडिबल हो और मैं ऑडिबल हूँ कि नहीं?
Actually, due to light cut off, we are not able to
Okay.
listen what you have said, sir. I just listened that we are going for lunch.
No, मैंने पूछा कि कंटिन्यू करना है कि लंच ब्रेक लेना है?
Sir, we will take, sir.
हाँ, okay, we'll take lunch break, और
Yes, sir. At 2 p.m. we will start, sir.
हाँ, शर्मा साहब, मैं ऑडिबल था ना?
सर आवाज नहीं आ रही सर मुझे।
हेलो, पार्टिसिपेंट को पूछना पड़ेगा, मैं ऑडिबल था?
Yes, sir. Yes, sir. Yes, sir. You are audible.
में लंच चाहिए सर।
या ओके। सो ऐसा आप अभी ऐसा प्रॉब्लम हो तो मुझे तुरंत बताओ, इफ आई एम नॉट ऑडिबल, या तो शर्मा साहब मुझे फोन भी कर देना।
Sir, there was some network issue at your end, because of which we couldn't get connected to you.
Right.
So we have the lunch schedule.
Sorry, sir. Actually, we are not able to hear you properly. What you said, it was because of the light has been cut off. We will take a lunch.
शर्मा साहब, आपका आवाज क्लियर नहीं है।
जी सर, अभी क्लियर।
हाँ, यस
सर एक्चुअली शेड्यूल में लंच ब्रेक ही है।
हाँ, ओके,
तो हम लंच ब्रेक ले सकते हैं सर।
ओके फाइन, सो विल टेक ए ब्रेक एंड 2 बजे फिर से मिलते हैं, ठीक है ना?
जी सर।
हाँ, है ना? और कुछ भी क्वेश्चन है, अभी कोई किसी का क्वेश्चन है तो मैं पूछ सकते हैं, कोई वी कैन हैव, मतलब ये अभी जो सेशन है उसमें क्वेश्चन है तो आई थिंक
Participants are requested to ask any questions if you have, or you can write in your chat box also.
So we have a compliment from the participants that it was a very nice session, very informative and excellent content, sir. That's what participants have responded.
right.
So participants are encouraged to ask questions. If you are not having it right now, please keep your questions ready. They will be addressed in the next session.
And next session will be, I think we can also extend, I don't mind, right? If we, right?
Thank you
Because
very
now
much.
we have a lot of experiments in the next session. We are going to demonstrate everything here, right? Through the videos, right? We try to understand the behavior.
Yes.
Yes.
Thank you so much, sir.
Okay. Thank you.
Thank you, sir.
Thank you, sir.
मैडम 2 बजे वापस स्टार्ट करते हैं। वो क्या अपना इको हो जाता है आपका उधर।